All right, we're back, and I hope that helped me stopping at that point. We can still see the problem on the board. All right, start with number 15. We have a drawing, looks like so. Okay, N, and this is L, this is M, this is O, P, Q. All right, so use this drawing to solve the problems. Arc MN is 50. Arc PQ is 30. First off, it wants us to solve for POQ. So where is that intersecting? In, out, or on? In, out, or on. Remember, in, out, or on. How you solve. If they're in, then what? Then you add and divide by 2. If they're out, you subtract, divide by 2. If they're on, you just divide by 2. So they're in. So it's going to be 50 plus 30 divided by 1/2, which is 80 times 1/2 equals 40. So our angle POQ is 40. Well done. Now, NOQ. NOQ. So now, think about this for a second. If this is 40 degrees, remember what this is. It's a straight line. So it's a straight line, so that equals 180. And we have 40 of it, so minus 40, what do you get? 140. So NOQ is 140. All right? Any questions on those two problems? All right. Awesome. Awesome. Awesome sauce. All right. Joseph, calm down. We're almost done. We're doing well. We're on number 17. All right? So, all righty, here we go. So we have our drawing. And it goes up to here, down to here. So this is H. This is I. This is J. Then we'll have inside of that, we'll have A, B, C, D, connect, and make this a little straighter. And then I'm going to go up to I. Okay, so that's what our drawing looks like. So now we can solve all the problems that go with it. All right, so number 1, if HI is 18, what is HJ? Now remember the theorem we just talked about for the proof. Theorem 9.7 says, if what? You have tangent segments to the same exterior point. Is this not the exterior point? Yes. So therefore, if this is 18, what is this one? 18. Well done, guys. Good. All right, next, BC. Arc BC, so that's this distance right here, is 50. What is BAC? So we're looking for that angle. So now remember, arc on central angles, arc equals angle, right? So if my arc is 50, what's my angle, class? 50. So my answer for BAC will be 50. Now, what would BDC be? So now, a little different. What kind of angle is this? It's an inscribed. And so what is an inscribed angle, class? What inscribed angle is what? It's arc, 1/2 arc equals angle. So if the arc is 50 times 1/2, angle is what? 25. Any questions? Everybody follow that? Can you see it clearly? Looks like, I can see it. All right, good. All right, so now, next question is DJB. What is DJB? Halfway around. So therefore it would be a semicircle. What arc is it? 180. Well done, 180. And it's called a semicircle. So now we got those. That's your two answers for number 19. Number 20, use arc addition to express JC. So JC, so this distance from here to here, and CB. It's just going to be from J to B. So your answer is going to be JB, arc JB. Okay, because it's, once again, is that a minor or major? Major has 3, minor has 2. Major has 3, minor has 2. That's why the C just drops out when you go JB. Wonderful. Last problem for this drawing. ACD. So angle ACD. So that's this angle right here. Is 48. First off, if this is 48, what's this angle here? Now we've got to remember, what kind of triangle is this triangle? It is an isosceles triangle. Well done. Why is it isosceles? These are both radii. AD, AC are radii. So therefore, if they're both radiuses, they're congruent. So that means this angle is 48. That means this angle here is 48. So if this angle is 48, class, what would be this arc? Well, according to our thing, is 1/2 arc equals angle. Angle's 48. So 1/2 arc times 2 times 2. Arc equals 96. Does that make sense? So that's number 21. So that was number 17 through 21. You can look it back at the answers through the answer key that Ms. LaScala will have. All right. All right, number 22. Almost done, guys. You're doing very well. I am almost done. That means I'm almost ready to go on my trip, which I'm sure you will be missing me at this point in time. However, you're just going to have to bear and hope that I'm having fun in the sun while you are sitting inside. Hopefully it's not raining, but most likely it's probably raining. So let's try these problems. XZ is 80. WY is 55. So class, where are these two intersecting? Where are they intersecting? Here's your intersection point. Is that in, out, on? In, out, on. Now remember, in is adding. Out is subtracting. On is just divided by 2. In, out, on. Riley, well done. Out is correct. So we're going to use 1/2 arc minus arc. So the first arc is 80. Second arc is 55. 1/2 arc minus arc is 1/2 arc minus arc. Arc minus arc is, so this is going to be 25. 1/2 25 is 12.5. So number 22 is 12.5. Okay, next problem. Once again, outside, arc minus arc. They give us the angle is 30. Angle's 30. AW, so from here to here, is 70. It wants us to solve ZA. So 30 equals 1/2 arc, because we don't know what the big one is, right? Minus the second one, which is 70. So how do we solve? First off, we multiply both sides by 2. And I'll do it out here. 2 over 1, 2 over 1. 60 equals arc minus 70. Add 70 to both sides. Arc equals 130. Questions? Anybody have any questions? All right, good. Last problem of this kind. CY, so it's from here to here, is 100. CX is 120. So we have our two arcs. We're solving for our angles. 1/2. 120 minus 100 equals. So 120 is 20. There's 1/2 is 10. Any questions? If you have a question, now's the time to raise your hand. And I will not acknowledge it because I don't know that you're raising your hand. All right, last problem. And I know that you might have problems over 9.6. Those of you that were away, I helped Maddie and Joseph, but we're just going to have to deal with it, some of you. All right, so this is 20. The radius is 6. So number 25 asks for the arc length. Well, what's the arc length, class? What's our equation? Fraction of the circle, 2 pi r. That's our equation. So, what's the fraction? 20 over 360. 2 pi. And what's my radius? 6. Cancel. 2 goes into this 18 times. 2 goes into 9 times. I'm sorry, 2. My bad. So what are we left with? 3, 2, so 2 pi over 3. These are my final answer. The next question asks, number 26, and I'm going to leave that up because that'll help me solve the last problem. Number 26 asks for the area of the sector. So fraction of my circle, pi r squared. So what's the fraction of my circle? 20 over 360. Pi r, 6 squared. So cancel that. 6 times 6 is, by the way, I'm going to leave this like this because I know what's coming. 36 cancel, I'm left with 2 pi. So area is this. Okay, once again, fraction of the circle, then my area. Next question, number 27. Let's go back over here. Number 27 asks for what is called the perimeter of the sector. So what's the perimeter of the sector? The perimeter of the sector is this distance plus these two. So first off, what are these two? What are the lengths of those two? 6 plus 6 is, right? Plus, what's this? What is our arc length? We already solved it. Simplify to 12 plus 2 pi over 3. And there's your final answer. So there's the chapter review. I know that took a little bit of time, but I wanted to do all the problems. That way you can just watch me do them, hear the justification. I know you can't ask questions, but at least you can listen through it. If you have still some questions, I'll answer them when I get back. Have fun, enjoy starting chapter 12 tomorrow, and it'll be have a good day. No homework, because we're starting chapter 12 tomorrow. If you did not do the homework, if you did not do it, please do it tonight. Practice it tonight. Make sure you got it. Have a good time. See you later. Bye.